the second section of chapter 5, which is verifying trig identities. So these first 5 steps here that I wrote down are guidelines to help you if you're stuck when you're trying to verify a trig identity. So you always work with one side of the equation at a time. And I always think that it's better to work with the more complicated side, but that's not always 100% true. But that's a good thing to try most of the time when you're stuck, is just to start with the difficult side, try to work it to the easier side. Look for factoring, adding fractions, squaring a binomial, or to create a monomial denominator. Remember, putting a monomial denominator means that you can split it up into more than one term. But if you have more than one term on the bottom, then you cannot do that. Look for opportunities to use the fundamental identities. So that's that whole front page of the last section that I gave you. Either the reciprocal identities, quotient identities, Pythagorean identities. So there's a ton of different things you can do, and that's what you're always looking for. A lot of those are dealing with sines and cosines. So if you can get your function all the way down to sines and cosines, that's the next step. That may be a good way to go, is trying to convert to sines and cosines. But number 5, I think, is the most important. Making sure that you always try something. So don't just stare at it and not know what to do. That might happen where you don't know what to do, but you should always try something. Even trying things that fail help you to learn something and figure out what you shouldn't be doing. So always do something. All right, so verify the identity. Secant squared minus 1 over secant squared equals sine squared. So we're always looking for trig identities. So secant squared minus 1 on top. If we think about the other trig identities that we had from that previous section, that front page, something that might look a little bit like this would be 1 plus tangent squared equals secant squared. So could I rearrange that to look like secant squared minus 1? Yes, I could, and it would be tangent squared. So that would be in the place of secant squared minus 1. Okay, remember, I'm not touching sine squared at all. I'm not going to multiply that across or anything. That stays over there. I'm trying to get tangent squared over secant squared to be equal to sine squared. Secant squared is the same thing as cosine squared on top. So dividing by secant is the same thing as multiplying by cosine. So let's do that next. And then tangent squared has a quotient identity that it would be sine over cosine. That follows for the sine squared over cosine squared. Our cosine squareds cancel. And we have sine squared. And I put a proof box when I'm done. Okay, this one we have fractions, so you know what to do. We'll get a common denominator. So the 1 minus sine x fraction we multiply by 1 plus sine over 1 plus sine. And 1 over 1 plus sine I multiply by 1 minus sine over 1 minus sine. If I multiply the bottom through, it would be 1 minus sine squared. Top simplifies to 2. Bottom simplifies to cosine squared if I'm looking at a Pythagorean identity. Dividing by cosine is the same thing as multiplying by secant. 2 secant, and we're done. Okay, so we have 2 binomials, tangent squared plus 1 and cosine squared minus 1. We want to see, before we try to FOIL that or anything, we want to see if either of those are Pythagorean identities that we can simplify. Tangent squared plus 1 is actually secant squared, which is an identity. And cosine squared minus 1 rearranged, so there's an identity, sine squared plus cosine squared equals 1. If I rearrange that and I want to get cosine squared minus 1, I end up with negative sine squared Okay, so that's what it rearranges to. I'm going to turn secant, if I multiply by secant, that's the same thing as dividing by cosine. And then sine over cosine is tangent, and I'm done. Negative tangent squared. Okay. Number 4, verify the identity tangent plus cotangent equals secant cosecant. Well, I think we're going to start on the left side, and I think that the best thing to do would be to turn tangent and cotangent into their quotients. So tangent is sine over cosine, and cotangent is cosine over sine. Now we have fractions, which we know what to do with. We need to get our common denominator. Okay, so getting a common denominator. On top we end up with sine squared plus cosine squared. On the bottom we have sine cosine. I hope by now we're recognizing that that top is 1 over sine cosine. And if I divide by sine, that's the same thing as cosecant. If I divide by cosine, that's the same thing as secant. And that is it. I'm done. I know that I make it look easy, and then when you're stuck on your homework, it seems impossible, but you always just have to try something so as not to get stuck forever. Okay, so here we have an identity, secant plus tangent equals cosine over 1 minus sine. And it looks to me, I remember in the instructions earlier, I said to work with the more difficult side, and I would say that the right side is actually more difficult in this case as a fraction. And we had an example in the previous section where even though we don't have complex numbers, we do something called multiplying by the conjugate, or you can say rationalize the denominator. I think that's what we'll say instead so we don't get confused. And to rationalize the denominator, we multiply by the exact same terms, only with an opposite sign in the middle. So we multiply by 1 plus sine over 1 plus sine, which will give us something good on the bottom. Top, not so much, but we can work with it. So we have cosine times 1 plus sine, which is cosine plus cosine sine over 1 minus sine squared. One minus sine squared is the same thing as cosine squared. Okay, now that we have one term on the bottom, it looks like it will be easy to split this up into two fractions here. And simplify. First term, one of the cosines cancels, so we have 1 over cosine. And second one, a cosine also cancels. Oops, not equals. I'll do a plus there. One over cosine is secant, and sine over cosine is tangent. And we're done. Not saying that you couldn't have started on the left side with that one, but I honestly think that it's easier to have started with the fraction side. Okay, this is one of those rare cases where I'm going to tell you to work with both sides separately because we're not going to be able to get there by just working with one side trying to get to the other. And it would tell you to do this on the problem. Normally we are never going to do this. We're going to only work with one side and try to get to the other. So don't do this just because this example does it. This is a rare case and I'm going to show you what to do, but all the other times unless specified, you are going to work with one side and work to the other. Okay. So we want to figure out if there's anything that we can do. I'm going to start with the left side, and I see that the cotangent squared can be turned into cosecant squared minus 1. That's a Pythagorean identity. Then that can be factored, which works well because one of the factors is the same as our terms on the bottom. So cosecant x minus 1 is as far as we can go on the left side. And then I'm going to work on the right side. Since it's a monomial on the bottom, I can split it up right away. And both of the simplified sides are the same, so we are done. So in that case, I could not have just worked with the left side and turned it into the right side, but if I simplify both, they do simplify to the same thing. So that might be something you'd have to do, but it would specify that. Okay, now there are so many different ways to do these, and I'm going to show you the way that I do it, but if your brain works differently and you figured it out a different way, that's awesome. That's one of the coolest things about these simplifying trig identities or verifying is because there are so many different ways to do it that almost everyone's brain has a specific way, and that's completely fine. That's actually great. Okay, so I'm going to start on the right side and factor out a tangent squared. Okay, then secant squared x minus 1 is a Pythagorean identity. It is tangent squared. That's equal to tangent to the fourth, and we're done. Okay, and let's do part B. It doesn't matter which side you start this one on. Some people's brain starts on the left, some on the right. It makes no difference at all. I'm going to say we'll start on the left, and since I see that I'm trying to get down to just one cosine, or one sine, excuse me, and we have 3 on the left side, then I'm going to simplify, break that down, because I know that sine squared is 1 minus cosine squared. And then it looks like I just need to distribute that cosine to the fourth, and I'll be there. There we go. And that was our section 5.2 on verifying trig identities.